Space is mysterious, and once in a while, looking at certain parts of it, we discover something that we were never expecting to find. Just like the new observation published on Nature on 27 January. A team of astronomers were mapping radio waves from within our galaxy while they saw something that was not supposed to be possible. They were using Murchison Widefield Array, which is located on the Murchison Radio-astronomy Observatory in Western Australia, to map our Milky Way galaxy, which operates in the frequency range of 70 to 300 MHz. Along with mapping the extragalactic radio sky, it also studies the Sun, the Earth's ionosphere, and radio transient phenomena. With the Australian Square Kilometre Array Pathfinder and 2 other radio telescopes in South Africa, the MWA is one of the 4 precursors to the international project known as Square Kilometre Array. When a team led by astrophysicist Dr. Natasha Hurley-walker was looking at a patch of the sky, they noticed something is releasing a giant burst of energy. They kept looking at it for some times and noticed it was pulsating 3 times in an hour. That was nothing alike they had ever seen. The object was actually discovered by Curtin University honors student Tyrone Dorothy. In every 20 minutes, the object becomes brighter, and actually, it becomes the brightest radio wave source in the sky for the moment. It stays like that for an entire minute before slowly fading and disappearing from our line of sight, just to appear again after 20 minutes. In the words of Dr. Natasha Hurley-walker, it was kind of spooky for an astronomer because there's nothing known in the sky that does that. The object is really quite close to us, just about 4,000 light years away. It's in our galactic backyard. If you can get your hands on a radio wave detector, this is where you should look in the night sky to observe the ghostly object. But for that, you will have to be watching the sky from southern hemisphere. Dr. Hurley-walker will now be monitoring the object with MWA to see if it switches back on just like a light bulb. And if she is successful in observing the object again, then every telescope in the southern hemisphere of Earth will be looking towards that. But sadly, according to Jeff Magnum of National Radio-astronomy Observatory, there aren't any currently operating radio telescopes in space. This kind of objects that turn on and off in a pattern aren't new to astronomers. They call them transients. Most of the time, observing transients mean either they are watching the death of a massive star or the activity of the remnants it leaves behind. When a massive star explodes, it leaves a dense spinning core made entirely of neutrons, a neutron star. Many neutron stars have extremely strong magnetic field, and as they spin, they produce radio emissions. As the radio beams pass over Earth, we see them appearing switch on and off like a lighthouse. This is known as a pulsar. There are a few kinds of transients, slow transients and fast transients. The slow ones might appear over the course of few days and disappear after a few months. Usually, they are supernovae. But the fast transients are most of the time like a type of neutron star called a pulsar. They usually flash on and off within milliseconds or seconds. The object we are talking about is none of them. It is somewhere in the middle of both kind of transients, and it spins. This kind of transients are so extremely rare that this is the first time astronomers were able to detect one. After a lot more research, this one may be classified as another kind of transient. The mysterious object was incredibly bright and smaller than the Sun, emitting highly polarized radio waves which suggest that the object had an extremely strong magnetic field. Astronomers are now suggesting that it could also be a magnetar, which is a special kind of pulsar powered by the rearrangement of twisted magnetic fields. Also, it could be a weird white dwarf too. These are the remnants of less massive stars just like our Sun. And of course, it could be something that we have not even thought of yet. Since 1965, humans have launched 3 space-based radio telescopes. The first one, KRT-10, was attached to Salyut 6 orbital space station in 1979. And then, in 1997, Japan sent the second, named Helka. The last one was sent by Russia in 2011, which was called Spectre-R and was a part of Radio-astronomy, which also retired in 2019. Actually, radio telescopes in space are sent with the purpose of linking with ground-based telescopes to form an array with very long baselines. Baseline is the distance between the antennas. Though in future there are plans to launch a few, if there were any radio telescopes in space, they would also take their turns to look towards the object. In theory, this kind of objects have been predicted before. These were called ultra-long period magnetar. But nobody expected to directly detect one like this because we did not expect them to be so bright. Somehow, it's converting magnetic energy to radio waves much more effectively than anything we have ever seen. Just like when astronomers detected weird radio signals coming from Proxima Centauri. What did that signal mean?